So welcome to this webinar. Today it's in English because I'm here together with Petri Heiskaari from Finland. Petri, how are you?
Fine, thanks. It's snowing here in Finland. I guess sun is always shining in Denmark, is it?
It's always shining in Denmark.
Yeah.
Today we're going to talk about ArchiFrame, which is a plugin for ArchiCAD that does timber framing and the detailing of wooden prefab structures. It can be used in different ways for different purposes, mostly together with automated CNC cutters. And Petri will show some examples from different offices using the software and also how the automation of the production works. And you also have some live models with you to show a little bit more precisely how this system works. So everything with ArchiFrame is always together with ArchiCAD. And it's a fairly complex way of working, but which brings a really automated workflow in the end that saves a lot of time. In Denmark, it's not that much used yet, but in Norway and Sweden and Finland, it's very common to use ArchiFrame together with ArchiCAD, together with perhaps a Hundecker cutter for the factory. So I don't know if you want to share your screen or you want to say a few words before that about yourself and your company, Petri?
Yeah, perhaps I'll do those at the same time. And thank you, Thomas. So I'm Petri Heiskaari. I'm responsible for ArchiFrame development. Yeah, as Thomas said, ArchiFrame is an add-on to ArchiCAD that enables you to model all the wooden structures all the way to the production. So we have companies using ArchiCAD from the first sketches all the way to the final production of CNC files. And it is a big benefit not needing to switch to another program, probably saving a CFC file, but to be able to continue inside one software all the way to the end. And where to find information, of course, our web page. And one interesting part from here are the references. And like Thomas said, we have a lot of customers from Norway, Sweden, and Finland. Also, we have some customers from Austria, Germany, South Korea. So totally, I think we have 18 countries. And what I am going to show is I have a short slideshow and then show some CLT structures, not really making those, but showing what the customers have made. And then I have a architect model of typical family house, the Finnish family house that we are going to make one wall all the way to the CNC codes for production. And in Norway, I'd say 90% of our customers, they are using some kind of CNC machines. The most common is this one, the cut saw. That cuts the pieces with the CNC file generated by ArchiFrame or similar softwares. So in this video, you see two typical tools, the saw blade and then the milling unit to make cuts to the wood. Then the other type is this framing station that is used after the cut saw. So it puts the framing together, then it nails and cuts the boards, and finally you can also use it to attach cladding to your elements. And the most used one is Weinmann Frame Tech with a WUP file format. Okay, and since today our focus is quite much on CNC, here is from our web pages, there is one article about CNC support. This shows some of the formats, or well, most of the formats we support from ArchiFrame and the different machines. Hundegger and Weinmann are the biggest ones. Then we have Swedish Randek and some Italian saws like Isär. So let's go to the slides. These are different types of buildings our customers have used ArchiCAD ArchiFrame to model for production. This is a Finnish example, a block of flats made from wooden elements. Everything is actually wood in this block of flat, including the floors. The foundations, they are concrete, but all the other parts here are stud framed walls and then wooden floors. And the production drawings. So not only 3D model, you will need these projections of your prefabricated elements to be able to build these.
And I love that on those element drawings, you also have the weight listed on top and also the balance point.
Yeah, so if you yeah, that's right. Yeah. So yeah, the weight is important to know that the element is not too heavy to be lifted at the building site. And also you can include the weight in the schedules. So that might be also defining what kind of crane you get to the building site when you know the weights of the elements. And for manual cutting, we have the cut information in the cut list. So the basic cuts like the slots for the beams and angled cuts, they can be expressed here in the cut list. And I think maybe I didn't tell that 90% of the customers in Finland are not using CNC, whereas in Norway 90% are using CNC. Must be something to do with the oil they get from the sea or ground.
And those element drawings, they are 100% automated, right?
That's exactly. So these behave like ArchiCAD section elevations, and yeah, you'll see working with those in the live demo. And another kind of building, this Tyrolean or Tyrolese timber frame house, everything cut with Hundegger CNC. So all these decorative endings, tenon mortise, dovetail joints, they are done with ArchiFrame and then produced with Hundegger. And more details of the same building and the detail of one part of the wall in form of ArchiFrame element drawing. Then a Dutch example from our partner design is this company designs the houses makes the architect drawings and then prepares the data for production. And this case, they used a company that used Hundegger Katso and Mobi1 framing station to build these prefabricated elements. So this company, they don't have their own production. Instead, they are more like design studio, and probably they are, in some cases, they are developers, so they build the houses, but without their own factory. And production drawings that they are using. Then the other today's topic, CLT buildings. This quite fresh Hungarian user, and what is interesting here is the way they use CNC machines. So they use standard Weinmann framing station to cut the CLT boards. Something I haven't heard anyone else doing. And usually the CLT cutting machines, they are very big and very expensive, and this framing station is something I don't know, maybe €500,000, much less anyway than those big CLT machines. And let's jump to the related ArchiCAD model. So this is the same model in ArchiCAD. And I cannot really show the architect phase because I don't have all the textures, and this model is more like a test model. But here you can see the different parts of the building. If we start from the top, the rafters, they cut with Hundegger cut saw, so they have used ArchiFrame to make the shape of these rafters. Then they have these interesting shaped CLT boards that they use the framing station to cut out these parts. And let's have a look of some details. For example, this connection of two CLT boards. They have used ArchiFrame tools to make these cuts. And as a proof, I'll write the CNC file for this. There is a metal connector that they tighten to pull these two boards tightly together. So select with ArchiFrame tools the CNC format for Weinmann framing station, which is WUP. Then save the CNC file with the file name CLT. A lot of settings. The last time I tried it, they were okay. And then let's see the resulting file. So we got actually two versions of this one. This first one is the composite, having all the layers that the customer can use to build this, assemble this in their factory. So they do this as prefabricated elements. And then,
so now you're in the special software for the boarding robot, right?
yeah, exactly. Yeah, this is Weinmann WUP editor, this software. And yeah, here at the bottom you see the codes that ArchiFrame generated for the CLT board. So we have the CLT, then this puff code. This is a milling route, so it will. This has all the separate cuts here.
Yes. So you're using it as a kind of a viewer to see how this will perform in the factory.
That's right, yeah. And this is exactly the same software that is used in the factory to run the machine.
Perfect.
Okay, so that's about this CLT model. Then I'll quickly show another one made by our Austrian customer Pearl. Kindergarten made from CLT, and let's switch the other layers off and see only the CLT. So we have CLT roofing. I'll switch that off also. Then we see the separate CLT boards, and let's have a closer look on this. So same stuff, some millings for electricity. And usually you don't produce CNC directly for CLT from ArchiFrame. Instead, you make 3D model like this, and then send it to the factory as IFC file. And they have their own software that can read 3D IFC and convert these all the cuts we have here into the milling saw cuts and other CNC operations. And I know these our Austrian customers, they have used at least factories Stora Enso, Finnish one in Austria, KLH and Binderholz, both in Austria. I don't know if you have those KLH, they have at least one factory in Portugal, but I don't know the factories, CLT factories in Denmark. So there's something, if you're using CLT, to go through the process all the way to the factory.
I'm not sure if we have any CLT factories in Denmark. The architects I've talked to who are working with CLT, they're all getting the elements mostly from Austria, actually.
Okay, yeah.
But I imagine that is changing slowly.
Yeah, it's expanding, and the same happened in Finland also. We export the wood timber to Austria, And then they used to make the CLT boards and take that more sophisticated piece of wood back to Finland. But now, today we have at least 3 CLT factories in Finland. So this has ended importing those CLT boards from Austria. But they must have been the first ones in this technology.
Yes, and for these 2 examples you've shown, I think CLT is also about the architectural expression and the feeling inside of the wooden structures that are probably going to be shown in the building. But often it will be cheaper and more CO2 friendly if you have light timber frames for your elements when you're doing 1 to 3 story buildings, and when you're building higher than 3 stories, then CLT will replace the concrete parts of the building, and have a more structural benefits.
And I think because of local regulations in Finland, the turning point from framing to CLT, that's about 5-6 stories. It might be that the fire regulations become so hard, tight for 6 stories or more buildings that then CLT is better, because I think it behaves somehow like concrete. So it has good fire characters. And here there's a typical thing. You have CLT at the inside, then you have insulation at the outside, and the framed wall, which is not load bearing, at the outside. Okay, then please ask anything, write to the chat or just say aloud. I'm switching now to another topic. So this is the framed house, typical Finnish family house is connected for 2 families, and this is made by Sievitalot. It is a company group that has their own architects and sales offices, and then they have Element Factory and also a third company that is actually building these at the building sites. So they get the biggest benefits because they already have a native ArchiCAD model. But yeah, we have in Norway, most of our users, they just get the factories, they get IFC file, and then they make the framing for production inside ArchiCAD ArchiFrame.
So if you're working with ArchiCAD and ArchiFrame, then you'll first do a model that looks like this, which is the architectural model. And that is done without really taking too much of the timber construction into account, right?
Yeah, that's correct, yeah.
And then you have, behind the scenes, you have a document with all the special specifications of your production, how large the elements can be, how they're put together in the corners, and all that is specified in an XML file behind ArchiCAD and ArchiFrame. And then you go from this model to the ArchiFrame project more or less with 1 click. Is that correct?
Yeah, a bit more than one click, but the process is about that. Yeah, you take architect model, or if you get only DVG, then somehow you have to make 3D model, but you need to have 3D architect model. Then there is structural engineer defining the detail sizes of the beams and the construction types to use, and then there is the constructor element designer making the framing for the different parts of the building, and then it's ready for production. And also you get, as you get from the good BIM model, you get bill of materials exactly from the 3D model. But yeah, here this was the architect model, and let's see what has been built inside the architect wall. So these are now only the load-bearing parts. So we have stud framing, trusses. These are prefabricated also. We have floor structures. And in this model, this is a real customer model, not made by us. So they have modeled these bulk shoes as realistic, real 3D objects here. They are separate objects placed manually. Of course, copy-paste is a good tool. When you model one, you just copy-paste, multiply it. And showing all the layers. So now you see the composites. We have the realistic cladding here first, and maybe I have a look on real external wall. Then we have the airspace between the windshield board and the cladding and the windshield board, and then the main framing. And I don't know if this is a Danish way also. So you have the main framing, and then very typical for Finland and Sweden, maybe also Norway, to have additional layer for insulation and installing electricity.
That seems right. Yeah.
Yeah. So let's do the magic to convert this wall. We had this is in the architect model. We have a wall here, but we don't have the arc frame. We don't have the framed structure. And yet to show where you can find arc frame, it's after installing arc frame, you find it in from options menu, and this is arc frame main tool palette. And let's go to the floor plan. And here I'll take the element tools, cheat a bit, take the settings from existing wall to get all these levels and settings to this palette. So I'm going to place the framing structure here to this wall that we hadn't made yet. And you don't have to follow the architect model one-to-one. Instead, you can make offsets. You can change the bottom level of the final structure, because the architect may not know how the wall connects to the floor. So it's what the structural engineer does. And in this case, it has to be 5 millimeters from this active story level. And then at the top, we will have trusses, so we will limit also the top side of the framed wall. Then maybe I briefly show where the framing, where the definition of our framed elements come. So this arc frame palette to define your composite. So we have different layers: cladding, the airspace layer, windshield board, and the most interesting one is the framing layer. And a lot of settings here. I show one of the most important ones. So the spacing of the studs, and then we have the main material ID, which is 42 by 198. And now I'm going to show the place for my element by line, showing the exterior side of the load-bearing core. So I draw over the architect model, and if this was very long wall, I could split this into 2 or more parts to have multiple prefabricated elements, but this is short enough to be lifted as single element, so that's fine. And our element got its ID from the architect wall, and I see architect hasn't really given ID, so now it is time to have unique ID for each of our elements. And let's see what we have now in 3D. So we have a placeholder for our structure. And before generating the internal structure, I set the corners also. So now the layers, they are offsetted according to the rules. So this the thickest one is main framing, and the exterior layers, they extend over the main framing. And the same in 2D. So here you see better how the corners are made. And also we defined some offsets for the top and bottom levels of the layers. So here the inside starts from higher level than the main framing and so on. And also we have the same settings for the opening. So here for the window, the Finnish way is to install the windows to the inner side of the wall. So then there is a metal plate taking the water drain away from here, and it's sloping downwards with these offsets. And then when ready with these, it's time to generate the structure by clicking this create blanks. And now ArchiFrame is first generating the main framing, and then the layers that are dependent on it. So again, what we got, the same structure. We have the cladding with realistic profile, the airspace strips, windshield boards, main framing, and then the additional layer for insulation and electricity at the inside. And
so it might not be done with a single click, but you don't have to model the structures manually. It's automated right, from ArchiFrame.
Yeah. And then one strong point of ArchiFrame is the flexibility. So you can edit whatever the automation does. You can work the ArchiCAD way, so you can drag these things around. You can delete those and edit as needed. One note about this, the corner. So this part was generated by corner rule, and for the connecting wall, this part, they are taught to ArchiFrame that when we have this type of corner defined here, we want to have these two pieces like this. And then let's see the maybe the single most important end result of ArchiFrame, the element drawings for production. And here you see the projection of the main framing only, and the weight without windows installed, and this is with windows. In the settings you can define what weights you have. So in this case, they are lifting these inside the factory, so then they are interested on this weight, and then at the building site when the windows are installed, this is the final weight.
And they're also interested in the balance point, so where to put the mounting
lifting
place.
Yeah. So there is the center of gravity to define the lifting points. And then we have the view from the top, and all this is generated automatically. So we have the dimension lines showing the offsets for different layers compared to the main framing. Here we have a stud dimension line to the left-hand side of the studs, and here we have the distance between the studs at the cut list. And then this is the view from inside. This is actually for cutting insulation. This factory, they cut this manually, so they need to know the widths for each space between the studs. And then we have dimension lines showing for the openings, so knowing how big pieces to cut from the insulation. And you might be wondering why this is not touching the other one. That's because this company has a rule that the minimum distance between the studs is 10 millimeters to be able to put the insulation between the studs to avoid air leaks between double studs. If you don't need this, then you can set it to 0. Then you will have pieces touching each other. And then the additional framing and the main framing as a kind of trace reference behind it, and the related cut lists. And then the windshield boards from outside. This is the element drawing setup made for this company, and they prefer Finnish texts. This means that element ID and then windshield boards from outside. Then we have cladding from outside, and again the related cut lists. So the automation has done its work. Then it's time to do something that the element designer might want to do. One thing, if you have CNC but not framing station, you can check on this option to have marking grooves. So then we will have shallow grooves pointing, showing where this stud should be installed.
So that means when you're on the factory floor and you're putting the element together, you don't have to make measurements on the drawing all the time. You just look at the number of the different parts and then kind of snap them into place because of this little groove.
Exactly, yeah. And yeah, for example, Swedish Derame, they are using these grooves. We have another option, is just to mark lines. But they like this because these kind of lock into place. So you can, with one hand, you can keep this in place and then use, for example, drilling tool or drilling tool to put a screw to put these together.
We like the marking grooves in Denmark too, because we all grew up with Legos. So it's just like putting Legos together.
Legos, yeah. So yeah, then what is unique to ArchiFrame, I believe, is the ability to really work on this element drawing. So I can drag a copy of this one. So you know ArchiCAD well, probably, and this exactly like ArchiCAD section elevation. So you can edit it freely here. So for example, make this kind of angled part, and then you can use the ArchiFrame blank tools to trim this. So I pick these two pieces as operator. And since we have the marking grooves, I use negative -5 millimeter gap to extend this all the way to the marking groove. So now you can continue the Lego. Putting Legos together, you have the locking places. And then a typical thing to add is a lintel or header, a beam above opening. So I select part related to the window. Maybe this best shown in 3D, so you see the result. So let's add a lintel here. So I select the material for lintel and then 2 beams to the front side and then 1 additional stud to each side. So some automation for typical construction. So we got this was shortened, this was added, and then we got these 2 beams and automatic slot for the beams. So let's say we are ready with this main framing, and you see this updated into this 2D element drawing. And you have just one detail to show. If I remove these beams, then the related slots, they will go away. So this bit like ArchiCAD solid element operations, but you get CNC codes. So with ArchiFrame, you should use ArchiFrame tools to cut the planks. Then what the element designer does to prepare this for CNC, let's add nailings and saw cuts for this cladding and windshield layer. So the first step is to explode this cladding, which is now modeled as single piece, to separate pieces. Then you also have full control of each cladding piece, so you can edit this freely wherever it's easiest in 3D ArchiCAD floor plan or sections, elevations, or these element drawings. And when ready, let's add nailings for the cladding. And I have a preset that will add 1 nail point to 30 millimeters from the cladding piece bottom and 45 from the top. So we got these marking, these nailings, nail markings also here to the 2D documentation, and also they are visible in 3D. So here, well, this is so dark, this blue, but maybe, well, now you see the markings here also. And then the other task the framing station is able to do to cut the opening and then the sides of the cladding let's add the saw cuts, not to the top and bottom, because we have horizontal cladding, and usually we try to get finish this into full cladding piece, and it looks it is the case here. Then the same to the windshield boards. So I take the windshield boards and the framing behind it and add nailings. I think this one will produce nice ones. So we got pretty dense nailing at the board edge. And also we selected to have a staggering here so that these are not so close to each other. And yeah, this what we did for this external part. These are the steps needed for the Weinmann framing station. And yeah, one question to the audience: does anyone do you have Hundegger CNC machine or the framing station to use in production? And to prepare for the final results, I need to update this element. So what this will do is it will assign similar IDs to similar planks and also update all the dimension lines and cut lists. This is the time. If you have multiple walls, then you can go and get coffee. And yeah, we have, because of the marking rules, we might have too complicated cuts to be expressed here. Then what you can do is, if I take, for example, this piece, single piece for manual manufacturing, you can add dimension drawing. I select one simple one, the big frame, compact, no text, no frame. So let's see this one. If I place this one inside the element drawing, so we get cut information for this single piece. And also, yeah, to finish documentation, one nice tool we have in ArchiFrame is this section with automatic dimension lines. So I define where I want the section and the watching direction, and then place it here. And we got a lot of information section of this with the automatic dimension lines. And then today's hot topic, CNC. So let's generate the CNC for the framing station. The format is whoop, and let's call it test. Some settings, and let's go on, and then let's see the resulting file. It should come here. And let's open this in the Weinmann software. And yeah, this should look exactly like it does in ArchiFrame, and you can believe that we have debugged this enough that this will be in the production. It will be exactly as you see it in ArchiFrame. So here we see the cladding with the nailings, and if I switch off that layer, we see the windshield boards, or the battens, I mean. Then ArchiFrame has added the markings for every fourth or third cladding piece, because the operator places these manually to the table, and then the machine shoots the nails, and yeah, it has to match what is modeled in ArchiFrame. Otherwise, the nails will be in incorrect place. And then yeah, we have the main framing here. And for the cuts, so if I save only the main framing in Hundegger VVX format, so this saving the CNC is something like it is a save as operation. Let's go with these settings. And I open the Hundegger software and take the file here and drop it here. Maybe that wasn't completed. Let's see if it's still thinking.
You're moving faster than the software.
Yeah, I am. Yeah, always happens, especially when presenting, you want to be too quick. So now, yeah, I know the Hundegger software is thinking. So let's wait for it to complete. So this is how the cut saw sees the things. The bottom plate having all these the grooves, and also we have the text here showing the ID, the blank ID. So in a factory, typically everything is printed and labeled. So if there is one blank lying around, you know from this ID external wall 99, you know it's this element, and inside element this part number 3.
So that will be marked directly on the wood when going through the CNC cutter.
Yeah. Our customers have different ways. Some use sticker, and the operator attaches the sticker to the plank, and someone they have inkjet printer to print it directly to the wood. And also Perfect. Here, this follows the 3D model. And that was about the live demo. Then maybe Thomas can tell more about BIM-X, but this could be useful to have the 3D model of some complicated connections, like here in the roof. In the roof, the guys could check at the building site, well, how this was designed to be done. And also you can have the element drawings in BIM-X.
Yeah, that's an easy way for people to find the information in the documentation. And it's still much more advanced than a PDF. You can jump between 2D and 3D. It's a free tool with ArchiCAD, and you don't need to have everybody signing in, having licenses. For the end user, they can just see the model and the project for free.
Yeah. And yeah, many of our customers, they're using this for having the complete structure, or then also for the building site to know only the element IDs. Now we see the main framing, but here the G is the element ID. So also when installing the elements, they can check, well, we have element K where it is supposed to be put at the building site. So they can have a look on this BIM-X.
And so I don't know if you have anything more to show.
Not really. There are other outputs like schedules, Excel listings, and so. But maybe let's stick to today's topic, CNC.
Yes. So I have a question from one of the participants. Who is primarily buying and using ArchiFrame in Norway and Finland? Is it construction companies or architects and engineers?
It's construction companies mostly, and then some engineers. So for architects, this we have without any license. So with a free tool, you can add some parts, or might take another model. Some parts like let's see these. So you could add these visible rafters with ArchiFrame free of cost, and then they are ready. If this is taken to production, these are ready for CNC. But the main users, they are the building companies and the engineers.
And often also what we in Denmark call savværker. So the milling companies that produce the wooden elements and nothing more.
Yeah, they actually, our customers, the engineers and house companies, they are using ArchiFrame to generate the CNC file for the sawmills. But usually the sawmills, they don't do this design work themselves.
Okay.
And yeah, also about the how to get how to try ArchiFrame. We have a free 1-month trial you can download from here, and if you download, you will get the instructions how to get started. And a warning here, it's pretty complicated to get started nicely with ArchiFrame, so please read the instructions, and then also in the email you get information about our weekly free support session. We have it on Tuesdays. You're free to attend, and of course you can always send email to support@ArchiFrame. Will help you getting started with ArchiFrame.
Yes. So of course, this is not a one-click solution, and of course, it's pretty complicated. But it adds efficiency and automation in a level that's much higher than an ordinary BIM is, just using ArchiCAD or Revit. And especially if you go for the direct link between ArchiFrame and the cut saw or the boarding systems, the automation level is really high.
Yeah. And also, about the customer groups, we have customers, small offices doing everything for family houses. Well, let's say in Finnish countryside, they do the architect drawings and then the building permit documentation, and then they make this framing plan also.
Yes. So, Peter, if you will unshare your screen, I will just continue a little bit. One question was what is the price of ArchiFrame, and ArchiFrame is priced exactly like ArchiCAD, so that's around 21,000 Danish crowns per license per year. It's floating licenses, and of course, it's not only expensive software, it's also a steep learning curve, because you have to match this with the type of wooden structures you want to produce and detail. And I'm just going to share my screen for a second to show that right now it's possible to get European funding from EU, and in the middle of May and then and again in November 2026, it's possible to get 50% of your expenses refunded from the EU if you have counseling for digitalization. So if you're dreaming about starting up with ArchiFrame, then you can spend up to 300,000 Danish crowns for consultancy, for help, for training, and then you'll get half of the amount refunded, so up to 150,000 Danish crowns, which will make it a lot easier and somewhat cheaper to get the knowledge built internally in your company to use these kind of tools. So if you want to go for the May emission, then you have to move fast, and we would love to help about this, to guide. And you have to submit your application May 11th. And if that's too soon, then in the middle of November, there will be another round again where you can apply for these European fundings. So please contact us if you want to try ArchiCAD and ArchiFrame together. And please also contact us if you want to hear more about how this works with the European funding. I think it was a really nice presentation of ArchiFrame. I love the way that you're doing this live, so we can see how easy it is, how fast it is, but also how complex it is. Of course, it's not as simple as modeling in SketchUp. But when you see these really complicated structures and all these detailed cuts of each part of the structure, I think it was obvious that a lot of it is automated through the software. So I hope that you enjoyed the presentation. Thank you so much, Peter, for spending your time doing this detailed presentation.
Thank you also from my side for attending, and Thomas, to you for arranging this one. Looking forward to help Danish customers implementing.
Exactly, and I think we have to match Norway, Sweden, and Finland in automating these wooden structures. I know that because of the new regulations with a demand for more climate-friendly buildings and a strict focus on LCA, we need to move from traditional materials to more wooden structures. not only for cladding but also for the structure of the building. And here CLT is probably going to be one of the main solutions, but we definitely had to move to more wooden, more use of wooden building materials. So hopefully this will change a lot in the future. Thank you to everybody who attended. Thank you for your questions, and I hope you'll have a great day. Goodbye.
Thank you. Bye-bye.